Hello class 12. In today's video, I'll be discussing with you the numericals related to rate law expression. But before that, let me tell you, if you have not seen the previous videos, then this video will be useless for you because all the topics are interconnected. So I would request you first go and watch the previous videos and then proceed with today's video. So children, in today's session, I'm taking up the numericals related to the rate law expression because in the last session, I explained you the meaning of rate law expression, the purpose of rate law expression, and also introduced you with the concept of order of reaction. And if you remember, the rate law expression tells us about the dependency of the concentration of the reactants on the rate of reaction. Now you can say how the rate of reaction is affected with the change in the concentration of the reactant species. Okay, and in context to that I explained you about the order of the reaction also, but that is not enough. We have to study the order of the reaction in more detail. So before proceeding to more details, let me make it clear to you by explaining it with the help of some numericals. As you can see, a very simple reaction is mentioned in front of you. The reaction is 2A plus 3B gives product. And the order with respect to A given is 2 and with respect to B is given as 1. So this is the given information. As you can see, order with respect to both the reactants are given. Then what we have to find out? Write the rate law expression. Okay, we have to write down the rate law expression and also we have to find out the overall order of the reaction. And then in the second part, we need to find out what will be the effect on the rate when the concentration of A is doubled and concentration of B is tripled, and in the C part, concentration of A and B both are doubled. So we have to find out these questions asked, but before that, what is the information given in the question is more important to us. The best thing given to you in the question is the order of the reaction with respect to both the reactants involved. When you know the order, you can very easily write down the rate law expression. As you can see here, the rate is equal to K, which is rate constant, into concentration of A raised to the power 2 because the order with respect to A is 2, and into concentration of B raised to the power 1 as the order with respect to B is 1. So this is very simple. You can see the rate law expression is mentioned here. Children, please recall the concepts from the previous video. Again saying, if you have not seen the previous video, then this is useless for you. So first go and watch that video in order to understand today's session. So what will be the overall order of the reaction? As I told you in yesterday's session, by summing up these parts, you will get the overall order of the reaction. Order with respect to A is 2, with respect to B is 1, and the overall order of the reaction, which is denoted by N, will become 2 plus 1 equals to 3. So your first part is answered now. Now coming on to the second part. In the second part, you have to find out the effect on the rate when A is doubled. So when A is doubled means the concentration of A is doubled. Rate law expression is already with you. When the concentration of A is doubled, what will happen? On squaring, you will get this expression. As you can see here, I have denoted it with R dash. Okay. So now this becomes your equation 2. Now how can you find out the change in the rate of reaction? Now in this case, you need to utilize your brain here. You will be on dividing equation 1 by 2 as I have done here. You can see here I have divided equation 1 by 2, and on dividing you will get this expression. Okay. Now the common numerator and denominator will get cancelled off, like K will get cancelled off with K, A square will get cancelled off with A square, and similarly B. So you are left with 1 by 4. and on simplifying you'll get R prime is equal to 4R. That means the rate of reaction will become 4 times the initial rate of reaction. Children, such questions are asked in your board examination, and I hope it is clear. It is quite simple. Then what is the second part? The second part is when the concentration of B is tripled. Okay, now when the concentration of B is tripled, what will happen? This will be written as 3B, and as you know, this remains the same. Now you can divide first equation with the third equation. The third equation I have mentioned, or the third rate I have mentioned, with R double dash. So on dividing equation 1 with equation 3, let us suppose this is equation 3. Okay, you'll get an expression like this: R upon R double dash equals to the same expression, but in this case it will be 3B. So B will get cancelled off, A square will get cancelled off, K will get cancelled off. Then you will have R upon R double dash equal to 1 upon 3. So finally the answer will be R double dash equals to 3R. That means on tripling the concentration of B, the rate of reaction is also getting tripled. So this is the second B part. Now coming to the C part. Now in C part, the question is the concentration of A and B both is doubled. Then what happens? In all the three parts, you can see that you have to relate it with the master rate law expression. Whatever changes is being carried out, you have to relate it with the first expression, that is this. Okay. Now see in the C part, A is also doubled and B is also doubled, and I have mentioned the power. Since you can see that the power of B is 1, whether you mention it or no, it is same. So on squaring, this will become 4, and this 4 when multiplied with 2 will become 8. So I have directly written here 8K A square and then B. Okay, so our triple dash is also with us. Now on dividing equation 1 with equation 3, what will you get? You'll get Ka square into B upon 8K A square into B. Now this and this will get cancelled off. Similarly this and this will get cancelled off, and in your equation you'll have only 1 upon 8. This will also get cancelled off. So 1 upon 8 is equal to R upon R triple dash. So you'll get R triple dash is equal to 8R. That means on doubling the concentration of both the reactants A and B, the new rate of reaction will be 8 times the initial rate of reaction. So this is how we calculate these questions, and these questions are generally asked in 2 or 1 mark questions, and it is very simple also to find out. Okay. In 2019 you got a question based on this only. The board gave a question based on such calculation. Most of the years, in most of the CBSE exams, we get such questions. So please children, try to solve it on your own also. Now the second question is written here, but before going through the solution, children, note down the question in your notebook and then pause the video and try to solve the equation, solve the question on your own, and then tally with the solution that I am giving you. First try to understand the question. Again, an elementary reaction is mentioned here. That means a simple reaction is mentioned here. 2A plus B gives product, and it is found experimentally when the concentration of A is doubled, the rate of reaction is also doubled. When A and B both are doubled, what happens? ROR increases, or rate of reaction increases 8 times. Whenever you see this square bracket, children, even if the term concentration is not mentioned, it means we are talking about concentration only if it is kept inside square brackets. Clear? Now write rate law expression and find order of the reaction. Okay, so first thing what we need to do is to find out the order of the reaction. Then only you will be able to write down the rate law expression exactly. But since we have no idea about the order of the reaction, we will simply write the rate of reaction in terms of X and Y, because we don't know what is the order with respect to X, we don't know what is the order with respect to y. So I've written rate law expression like this only. Then what is the second part saying? It is saying when A is doubled, ROR is also doubled. That means the second equation that will be found will be 2R equals to when A concentration of A is doubled. Okay. Now third is saying the rate of reaction is getting 8 times when both are doubled. So 2A and 2B in concentration and the rate of reaction is 8 hours. 8 hours. So you have three equations here. Now you have to apply your brain here. Which equation should be divided with what equation in order to reach to the value of x and y. So what we'll do first, divide equation 2 by equation 1 because you have these two in commons. So these two will get cancelled off. So I'm dividing equation 2 by equation 1 as you can see here. Equation 2 is this, 2r equals to, as written here. Equation 1 is this. Now on dividing k will get cancelled off, rr will get cancelled off. This a raised to the power x, a raised to the power x will get cancelled off, b raised to the power y and b raised to the power y will get cancelled off. You will be left with 2 raised to the power x because this x is applicable to both 2 and a. So you'll get an equation like this. Now you can see here, you have base as 2 on both the sides of the equal to sign, and 1 to this 2 the power is 1, to this 2 the power is x. So the value of x will be 1. So you can see here the order of reaction with respect to A will be 1. I hope this much is clear. Now when you have to reach to this value of y, obviously you will be dealing with these two equations. So or you can also solve 2 and 3 because now you have this value with you. Okay, but I have done with 1 and 3. So now when you divide equation 3 by 1, as you can see here, the equation will get modified like this. R and R will get cancelled off. A raised to the power 1, A raised to the power 1 will get cancelled off. K will get cancelled off. 2 will remain here. B raised to the power y, B raised to the power y will get cancelled off. But 2 raised to the power y will be in the question. In the equation, as you can see here, the equation will get modified as mentioned here. So you can write 8 as 2 raised to the power 3 and this side applying the simple basics of indices or exponential equation. You have 2 in multiplication and the power of this 2 is 1. So this can be written as 1 plus y. Now this 2 and this 2 will get cancelled off. It will give you the value as 3 equals to 1 plus y. So the y will be 2. Okay, so order with respect to b is 2 now. When we have both the orders, that is the order with respect to a is x, which is now 1, and order with respect to b is y, which is now 2. So the rate law expression can be written with the value of orders as this. So one part is answered and the another part is to find out the overall order. Overall order will be 1 plus 2 equals to 3. So now we have the answer to both the parts. So I hope this question is also clear, children. Again, these concepts are very simple and very much important for your board examination. So children, please try to solve these numericals on your own, and I'll be sending you some more numericals of such type for practice. Now moving ahead, since we have done quite a number of important points about order of the reaction, so here is just a summary of important points about the order of the reaction, out of which most of the points I think you are aware of if you are following the lecture sincerely. So first point says stoichiometric coefficients have nothing to do with the order of the reaction. Okay, so this I told you in my previous video also, that order of the reaction is totally experimental. This can only be obtained with the help of experiment. It has nothing to do with the stoichiometric coefficients or the balancing moles present in an equation, okay, which was according to the law of mass action. Law of mass action is applicable only to few equations, children. It was given by Goldberg and Weig, I guess, yes, but the law of mass action is only applicable to few equations where you will find that the balancing mole is raised to the power of the reactant or the product in rate law expression, but actually it is not applicable in case of all the equations. We have to follow the experimental data, which tells you altogether a different story. So here you can see that with respect to reactant, the balancing mole is 2, the stoichiometric coefficient is 2, but here the power is 1. This data is obtained experimentally, and obviously experiments never tell lie. We have to go according to experimental data only. So this justifies, this is an authentic example, and it justifies that stoichiometric coefficient is not the same as the order of the reaction. And coming to the next point, product can also be considered in rate law expression. Children, this point I have mentioned here, but you will not get expressions in which order will be utilized up to your class 12 or board level. This type of question you might get in your competitive exams, but in your board level you will be only dealing with the reactants in the rate law expression. So you can see here ozone is getting converted into oxygen, but in the rate law we have both ozone and oxygen. This should be 3 actually. Okay, ozone and oxygen. So this is again an authentic example calculated experimentally, where the rate of the reaction depended upon both the concentration of oxygen and ozone. Then moving on to the next point, some reactant may be absent in the rate law expression. Like this is a reaction, but in the rate law expression you can see here that NO2 raised to the power 2, CO raised to the power 0. That means anything raised to the power 0 means 1. So in the equation you will find that finally in the rate law expression there will be only existence of NO2. Now raised to the power 0 means the rate of reaction does not depend on the concentration of CO at all. Whatever you do with the concentration of CO, there will be no effect on the rate of the reaction. But you can see with respect to NO2, the rate of reaction, the order of the reaction is 2, and the overall order of the reaction will also be 2 here. Okay, and I told you in my previous lecture also, the order can be 0, negative, positive, fractional, anything. So if the power or the order of any reaction with respect to any particular reactant is 0, that means the rate of the reaction does not depend upon that particular reactant. I hope this is also clear. So moving on to the last point, concentration of catalyst may be present in rate law expression. So in some cases, children, you will also observe that the rate of reaction is also depending upon the concentration of the catalyst. As you know that catalyst is one of the factor on which the rate of reaction depend. Recall the previous video, children, where I discussed about the factors affecting the rate of reaction. Then I discussed with you the catalyst. Okay, so in certain reactions you'll find that the concentration of catalyst is also playing an important role. So here you can see in the rate law expression the catalyst NO is also mentioned here, and it is directly proportional because the order with respect to NO is 1. Okay, so these are some important points with respect to the order of the reaction. Most of the points I've already taken up with you. So here is just a summary. If you can note it down somewhere, it will be easy for you to recall the concepts that you have already learned. So children, and one more thing very important is this, that order of the reaction can only be calculated experimentally or can only be depicted experimentally. Theoretically, predicting the order of the reaction is impossible. So I hope today's lecture is clear. In today's session, what we have done, in today's session we discussed about the rate law and the order of the reaction with respect to or with the help of two numericals, which are simple, and I expect you to practice it on your own also. And also we have covered up the summary, which are the important points about the order of the reaction. We'll proceed further with the same topic in my next video, and thank you for watching the video. Have a nice day.